In this demo, we're going to talk about hashing algorithms and what they can do for us. Hashing algorithms have been around for some time. Some of the older hashing algorithms include MD5, which produces a 128-bit output, and SHA-1, which produces a 160-bit output. Now, any small modifications to anything, whether that be a single letter or an entire file, single letter in a word or the contents of an entire file, can be detected by comparing the hashing algorithm, the hashed output of the file before you made the change, with the hashed output of the file after you made the change. So in this example here, I'm going to create 4 files, and they're going to have the word Cali in them, but they're going to be variations in spelling. So I'm going to echo all lowercase into file 1, and then I'm going to echo capitalized Cali into file 2. Then I'll create another file. It's going to be all uppercase. Into file 3. And then finally I'm going to echo and swap out the letter capital I for the number 1. That's going to go into file 4. All right, so there are a number of hashing algorithms that can be used. As I mentioned before, MD5 creates a 128-bit hash. SHA-1 creates a 160-bit hash. But the problem with those two hashing functions is that we have the possibility of two different inputs actually producing the same hash value, and that's called a collision. So in order to avoid collisions, one way to get past those is to use longer hash outputs. So today what you'll see when it comes to storing passwords on Linux systems, at least, MD5 and SHA-1 typically aren't used anymore for the hashing algorithms on those modern Kali or Linux systems. Typically you'll see them using hashing functions that are of the sha256 or the sha512 variety. So we can go ahead and compute the various hashes of these 4 files. So let's use the sha256 as an example. So if we run sha256sum against file 1, that produces this 256-bit output. Now each of these characters, if you count up the number of characters you see there, multiply that times 8, you'll see that that's actually going to be 256 bits. So that's the SHA-256 value of lowercase Cali. Now let's see what happens when we capitalize that. Get a completely different hash. Whereas the previous one started off with 101, this one starts off with lowercase a25. Now let's see what happens when we have all capital letters. Again, the hash output of that particular string is completely different than the previous two. Now let's see what happens when we have the capital K, capital A, capital L, and then the number 1. Here you can see we have completely different output from the previous 3 files. So even though we've got some minor changes to the actual word that we're trying to run the hash on, we end up with completely different hashes.